Okay. Okay, so make me host once again because I need to share the screen. You record it. Make me host. Thank you. Sorry. Okay. What type else? Right. One question could be very common, like I am plotting output characteristics of BJT in CE mode. So what do I plot? Option A is IE as a function of V, CE, and IB. B could be VB as a function of VCE and IB. C is IC as a function of VCE and IB. D is VCE as a function of VB and IB. So which one do you think is correct? Which option you think is correct? Yes, C, right. So this is the thing. If you know the answer, it will, how much time will take you? 10 seconds? Now I can change it, make it common base. For common base, what will be the answer? Assuming, I do not know whether it's there in the option. Can you write it the answer if it is not there? Had I made it common base? The correct answer is not there in the choices. So what would be the correct? Can you write the answer here in the chat? IC and VCB. Yes, but I am plotting output characteristics. So IC as a function of VCB and IE. Very good. Exactly. Yes, right. Correct. Please mute whoever is. Okay. What else could be? Okay, I'm giving the problem right from my mind. So if the problem answer is somewhat wrong, please don't blame me because I do not giving a book. I'm just thinking of it. I have got an E MOSFET. Okay, I have an E MOSFET, N channel E MOSFET, N channel, right? Now, V threshold of it is plus 2 volt or minus 2 volt. Which is the correct answer? What would the V threshold of that? Plus 2 volts or minus 2 volts? Which is possible? Tell me. Then I will go to the one problem. The threshold voltage of an N-channel E MOSFET is greater than 0 volt or less than 0 volt? Yes, plus 2 volt. Very good. So this plus 2 volt. Right? Now, when VDS is 5 volt, ID is say 20 milliamp. What is ID when VDS equal to, wait, when VDS equal to 1 volt? What could the answer? If VDS is 5 volts, then ID is 20 milliamps. So what is ID when VDS is 1 volt? Sorry, VGS. No, sorry, VGS, not VDS. VGS. This would be VGS, not VDS. Anybody can try? When VGS is 5 volts, ID is 20 milliamps. What is ID when VGS is 1 volt? So what formula we should use? Anybody? There are of course 4 choices there. Okay, I'm not going into that. So how to solve this problem? How to solve this problem? This is the easy part. Anybody? Once again, I expect you to answer this question without any hint. You understood E MOSFET, you will be able to answer this question straight away. Threshold voltage is given. This is given that VGS is, for VGS is 5 volt, ID is given. So what is ID when VGS is 1 volt? Anyone? I expect to get an answer right by now. It's not at all difficult. How can the ID be 1 volts in volts? Nivedita, tell me. How can ID be in volts? Anybody? I expect an answer. When does a E MOSFET start conducting? No, that's a wrong answer. Sorry. Even with 1 milliamp, it's the wrong answer. When does an E MOSFET start conducting? I discussed it, these things at least twice. When does an E MOSFET start conducting? What is the basic difference between a D MOSFET and E MOSFET? Anyone? I should have got an answer by now. And the correct answer. When does an E MOSFET start conducting? I think I've explained this twice at least. Anyone, please. What is the basic difference between a D MOSFET and an E MOSFET? Okay, I will not solve this problem. You try to find it out. So there are two parts. This is a part A. This is a part A. Part B is the same thing. No. Part B is this. You note it and you solve the problem and you will the answer. Will there be a channel when the VG input voltage is 0 volt? There is a formation of channel. How the channel forms? Yes, right. So how to connect the how exactly? তাহলে E MOSFET connect করতে গেলে কি করতে হয়? We need to form a channel. How to form the channel? I've told you these things. Okay, you take a look at this problem. It will be in your YouTube. Think about this and give me an answer. Okay, everything is given on your board. Okay, something else. Extra battery. How? Where? কোথায় দেবে? Where do you want to put it? Okay, think about this and give me the answer. What else? Near gate. Exactly. Think and you will get the answer. What else? Gate to source voltage with PTH. That what does that mean? You think about it. I will not discuss this problem. You think about it and let me know the answer. Hmm. This is plus 1 volt. This is 10 kilo ohms. This is 100 kilo ohms. Sorry. This is 100 kilo ohms. What is V out? V in is plus 1. Let us write it clearly. VCC and VE are given. Okay, I have not drawn it, but they are present. This is plus 1 volt. So what is V out? Anyone? What type of amplifier is this? No, why square wave? And this is a DC voltage. Why will you get a square wave from out of nowhere? Op amp is that IC. What is that amplifier configuration? Okay, probably have not revised it. So let us go back to BJT. This is a non-inverting amplifier, right? I told you. The gain was minus RF by R1. Right. What else? There could be some very easy problems like if alpha equal to 0.98, what is beta? How to find? Right.
Sir, beta equals to the alpha by 1 minus alpha.
Exactly.
তা ওখান দিয়ে ক্যালকুলেট করে নিতে পারবো।
Right. What else? There is a silicon diode and there is a germanium diode. Which one will you prefer to put in your circuit?
Sir, silicon diode.
Why? For the applications you have seen, silicon diode is preferable. There is one application, however, which I have not taught you because that is not in your syllabus, where germanium diodes are preferred. That you will study, I think, in your third year. VB is low, then how germanium offers less resistance? What type of less resistance? For germanium, the idea is for germanium, this reverse saturated current is much larger, okay, than silicon. So more often than not, silicon is. However, one particular application, which I have not taught you, as I told you, where germanium runs. Out of bridge rectifier and full wave rectifier, which will you prefer and why? Out of bridge rectifier and full wave rectifier, which one you prefer and why? Full wave, I mean by center tap transformer, not
Sir, bridge
center tap
one.
transformer.
Because it is more effective.
How it is more effective? And what do you mean by more effective? Modern charger circuits are much more complicated than you think. But yes, our answer is right. It is using charger. The biggest disadvantage, what I told you of center tap, is that you need a transformer and find the exact center tap. You have broken a charger and seen. What have you seen? Modern chargers, they have more electronic circuits than you think and you have been taught. But the rectifier part is of course there. Polygon shaped rectifier. Did you see capacitors, Amit? Yes. Capacitors have a function. What else? Which diodes have more doping in concentration? The Zener breakdown diodes. Step down transformer we have seen. That's interesting. Was it a very old charger? Yes, Zener. Why? Zener has higher doping ones than the normal diodes. Why? And Amit, is it a very old one? Step down transformer we have seen? Nokia. Okay. Modern depletion region is narrow. Very good. So that's right. So there will be higher electric field. That would be. Oh, repeat the question. Zener diodes are there and normal diodes are there. Which one is supposed to have more doping concentration and why? Question. Modern chargers don't have they actually have transformers, but not the reason what we have discussed. Those step down numbers are big and they make the things heavy. Depletion region narrow, more charge carriers will pass. So it has got something to do with electric field. It has got to do with higher electric field. More the electric field, more it will be easier for the electric field to tear out carriers from the atoms, what we have discussed. EF is higher. Oh, electric, yes, electric field, right. Okay, it is like question practice. If you find, go to net, you search basic electrical, basic electronics, MCQs, you get plenty of sites and plenty of questions to practice. Okay. Anything else? Can you think about a MOSFET question, which I gave you? That question is unsolved. Anything else? Any other question or we close down? Okay. This is the symbol of which component? If you take embedded systems, maybe, but later, much later. Much later. In the embedded system class, it will be taught under CSD, but higher, much higher. It's sixth, seventh, those times. This is a symbol of which component? Anyone? Varacted dub, yes, right. That's the right answer. Varacted dub. Okay, this I haven't taught you, but just for curiosity. This is the symbol of which component, can you know? I did you know? I didn't teach you. So I'm if you don't know the answer, it's fine. I didn't teach you. But it's a very, very common electronic component. For which this is used for which type of electronic component. Very common. Much more common than vector diodes. No, not related to capacitor. Very common. You have seen it. You can find it everywhere. Yes, light emitting diode. Very good. This is a symbol of an LED. LED. Yes. Yes. This is a symbol of which component? Which type of MOSFET? It is MOSFET, but what type of MOSFET? More specifically? D MOSFET or E MOSFET or N channel or P channel? D MOSFET, right? N or channel or P channel? D MOSFET is right. N channel or P channel? This is a N channel D MOSFET. Okay. This arrow is coming in, that shows N channel. Exactly opposite to the BJT convention. In BJT, the arrow coming in shows PNP transistor. The arrow going out shows NPN. But in FET, it is opposite. The arrow comes in, it is N channel. If it goes out, it's P channel. Okay. Okay, thank you. And if you want, we will next week will be the last week before the break for the exams. So if you want, we can have 1 or 2 classes in the next week, right? And you solve the questions, the MOSFET question. Okay, thank you very much. Good night.
Sir, then I'm stopping the recording.
Yes, yes, please do. Please stop the recording.